Angle sum notes. A polygon is a closed shape with 3 or more straight sides. A diagonal of a polygon is a line segment connecting any two non-adjacent vertices. And I will explain what non-adjacent means. So a triangle does not have any diagonals because at any given vertice, all the rest of the vertices could be considered adjacent or right next to. On a square or quadrilateral, if I pick one corner, I can draw in one diagonal. Go ahead and do this with me, please. A pentagon, pick one corner. So if I drew to an adjacent vertice, I would just create the side. So that's how you know that you're creating a diagonal. Hexagon, pick a corner, draw in diagonals. So that's line segments again to non-adjacent. So this corner immediately to the right and the corner to the left. This corner and this corner, those would be your adjacent, okay? So using the idea of the number of diagonals in a polygon, we created triangles. So in the degree discovery, we saw that the number of the pattern was increasing by 180. So a triangle has 3 sides, quadrilateral has 4, pentagon has 5, hexagon 6. Ingon, that means any number of sides. In number of sides. Any number of sides. So how many triangles were inside the triangle?
None.
Or
1.
1. And quadrilateral had
2.
Pentagon, hexagon. Okay, so what's that relationship from 3 to 1, 4 to 2?
It's just 5 to 2.
5 to 3, 6 to 4. So the number of triangles in any polygon is going to be n minus 2. So that's another way to see the minus 2 relationship. Okay, so we have that consecutive pattern. So from our table we had 180, 360, because the number of triangles is 180, 2 triangles is 360, 3 triangles is 540, 4 triangles, 720. Because I was increasing by 180 each time, my equation would be n minus 2 times 180. So the formula, y equals n minus 2 times 180. Let's apply that rule on the next examples. Find the sum of a decagon. How many sides does a decagon have? 10. Okay? So 10 sides. I don't need GeoGebra for this. I can use my equation. So 10 minus 2 times 180. So 8 times 180. Justin, can you help me out here?
It's 14,400.
440?
Yeah.
All right, 1,440 degrees. Go ahead and put that degree symbol on there for me, please. So I can use my equation to work forwards to get the degrees. I can also use my equation working backwards. So on example 2 here, it says the sum of the interior angles of a polygon is 6,480, classified by the number of sides. So is it going to be a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, up to 10? And if you have a shape with more than 10 sides, so 10 sides up here was decagon, right? If you have 11 or more sides, this is just called a 11-gon. You just put 11-gon, 12-gon. Okay? So all the way from triangle, quadrilateral, pentagon, hexagon, heptagon is 7, octagon is 8, nonagon is 9, 10 sides is a decagon, but after 10, there are bored mathematicians who have named sides like probably up to 150-sided shape using Latin, Greek prefixes, whatnot, okay? But after 10, I don't need you to memorize any. Some of you might know that a 12-sided shape is a dodecagon, but it's just 11 gons, 12 gons. So a 15-sided shape is a 15 gon. A 30-sided shape is just a 30 gon. Okay? So any number of shapes dash number of sides dash gon. All right, back to example number 2. So the sum of the interior angles is 6,480. So I can take that answer and set it equal to my equation. So n minus 2 times 180 is 6,480. Some of you possibly already have this answer because you are really good at trial and error, guess and check. You've just been working through your calculator. 4 times 180, 5 times 180. But what if this is 1,000? I don't need you guessing and checking. We can solve this like an equation. Okay? So this 180 is attached to the parentheses by multiplication. So 2 things you can do. You can distribute that 180 and then take a 2-step equation to solve, or we could simply divide both sides by 180. Can you help me out with the calculator here? 6,480 divided by 180. 36. And then I would get my n by itself. I would add 2 to both sides. Again, an answer. This is 38. So that's how many sides this is. This is a 38 gon. Okay? So, we already know the definition of a regular polygon. Regular polygon is a polygon with congruent sides and angles of equal measure. So all the sides are congruent and angles are equal. So some examples here, I wanted to show you some markings. A 4-sided shape that is regular is a square. To show equal sides, you can use tick marks on the sides, and you can do arcs. However, a square that's equal, we know, is 90 degrees. Okay? That pentagon, I'm going to do my best to draw this so it looks regular. It's not quite regular, but I can tell you it's regular by putting tick marks on the sides and putting arcs in the angles. So even though that's not drawn to scale, these markings say, hey, I wanted that to be a regular pentagon. And you can do that on any shape using tick marks. Okay? You could also, let's say you wanted to show that the square wasn't the same size as the pentagon, you could go back and you could put 2 tick marks on the square. So those sides are equal on the square, but they're not the same size as the ones on the pentagon. Okay? So you can use your same equation, just one more little bit here. This would be a good stopping place after this one. So the measure of a nonagon, how many sides was a nonagon? 9. So my equation is n minus 2 times 180 divided by n. So this is going to be 9 minus 2 times 180 divided by 9. Or 7 times 180 divided by 9. Make sure you don't divide by 7. Most students do a great job subtracting 2 on the numerator, but then they don't divide by the right thing. Okay? Our final answer there, anyone type that into their calculator yet? My key's in the back of the room. Anybody? Hercules, can you help me out here? 7 times 180 divided by 9. 1260. Each angle's 1260. Can you divide by 9? You did 7 times 180, you got 1260. Divide by 9. 140. Okay. Give me 1 second before you leave. Stop.